Hi guys, and welcome to part 12 of this series of videos on creating a relational model. So the part 11 we finally managed to get the nightly build kicking off, and the nightly build failed due to some weird errors. Basically code generate is misbehaving at present. Whilst you guys were away, I had a quick look at the coverage issues and I got to the bottom of it. I'm gonna quickly explain to you what happened. I still haven't got a green build that uploads coverage, but I think we're very close to it now. So if I take any of these builds, this is like a sort of a comedy of errors, I guess. So this build has got coverage set to 1. If you have a quick look at what Keikov was saying, you could see that we had a whole lot of errors here. Now, lib opcode, as it turns out, is part of bin utils, and what happened was, we for every release of for every build machine that we've got in Travis, we tend to do a download of the VM of the ISO, I guess, of that release, and then we build all of the stuff, so VC package, Keikov, everything in that machine. And what happened a couple of months ago was that we've moved from whatever release was at the time, 1404, something like that, over to Xenial. I'm not quite sure how you say that, how you pronounce that. When we did that, we lost code coverage, and the reason why we lost code coverage is because the version of binutils that we had for Keikov no longer matched the version of binutils that was being used by Xenial. Now we didn't notice this was a problem because, as I say, one of the things we always do here, we should be clocking something. We can put this as time spent recording videos because we're just talking about the past. So one of the things that we do is we always do the simplest possible thing when we're trying to do something. So if I just git time machine this file, and so what we had was this, very, very simple. It literally ran Keikov, and it just uploaded the coverage either to coveralls here and to CodeCov here. But as you can see, if there's any errors, they're just being silently ignored. And provided that this bit here works, the script will then return status of 0. So that's why we're getting all these errors, but no problems, because this chap here is saying, oh look, no coverage, nothing to report, everything's fine. So what we did then is, right now go to the future, what we have done is we now put a little bit of error checking here, and we exit immediately if there's a problem. We also put that logic that I discussed before, where we don't want to upload both to coveralls and to CodeCov. We want to upload to one or the other. So we put a little blurb here explaining why it is that we want to do that. And again, a bit of a hack, I guess, but we just did it very quickly. If there is no coveralls ID, then we basically don't bother uploading to coveralls. And if there is no coveralls ID, then we do the CodeCov. So hopefully this will then mean that we upload to one or the other, or not both. So coveralls will now become our CI coverage, and CodeCov for the nightlies. And we did something similar for the reference model. So that's all been pushed. Unfortunately, I was hoping that Travis would give us a nice clean build, but keep on having very strange errors in Travis. So I'm just going to leave it to it, because Travis sometimes can be very, very, how should we say, have a lot of personality, shall we say, and so we can have lots of strange errors related to networking and all sorts of things. So we just leave it to it, because at some point it'll stabilize and we'll just move on with our lives. And then at some point we'll just we'll double check, because we have a story, and the story is open, as you can see here. So once we've finally confirmed that that's working, then we can go and resume and close the story, should I say. So then, if we go back to the actual task at hand, which is, we are trying very hard to figure out what's going on with the nightly and why it is that we can't build. So what we need to do is probably to say, this is a story on its own, isn't it really? We should probably say this is not really directly related to creating a test build, so I'm just going to open up the story here, and I'll say so the name of that feature that we're using at present is full generation, right? So if we just say something like full generation produces invalid codes. Well, and then we can say something like when using full generation to build the Dogen model, no, actually the Dogen, the utility model, we generate invalid serialization for declarations. Declarations for serialization. They are missing the includes. We need to understand what causes this and fix it. Something like this, just so we know what this work's all about. And that would be 48 that we started. Okay, so the way we're going to tackle this, I mean, there's many ways you could tackle this, and of course, if we had the relational model, we could just be querying a database. But we don't, so instead of getting lost in lots and lots of debugging, what we're going to do is we're just going to take the utility model and we're going to set this to be test all facets profile. And what hopefully this will show us is whether the problem is with overwriting or something else is wrong here. So we have a nice clean build here. So if I just generate Dogen.utility.dia, and if we just have a quick look at the result of this generation, first thing is, before anything else really, let's just try building it, because just expect to see the error. So right, excellent. So as you can see here, there's nothing particularly special about overrides. We're getting exactly the same error, so that's a good thing. Whatever is causing this problem is not due to overrides. We seem to, for some reason, not be wanting to generate. If we can find our log files. We seem to, for some reason, not be wanting to generate the inclusion expansion. So now, what could be causing this? Right, so let's try to go through the code, well, to the log file first. So as you can see here, for every class that we go through, of course this is still using the old C++ approach, which is part of the thing that we're actually trying to solve in the first place. That's the reason why we're going to the relational model, if you remember. To recap, in the olden days we used to have some meta-model entities inside of the C++ generation model, and these meta-model entities here, they were used inside of, well, directly inside of the generation. Now this is not a brilliant idea really. So what we figured out in the end was that actually we should just have a single meta-model, which is what we now call assets. And this meta-model, I mean, this is quite a large thing really. If I just zoom in, you can see here, this is the meta-model. The idea is to just grow with meta-model entities in here. But sadly, because we're still in the old world, what you see here in C++ is we're making use of a thing called formatables, which is another entity that doesn't really make any sense really. It's just we were discovering the problem domain, so we ended up creating a lot of these entities that very special, I guess we could say. And the formatables are just basically a pair or a pairing or a tuple of different kind of meta model elements. And some of these meta model elements are these ones you see here. Most of them come from assets. Now, inside of this C++ generation model, we have a number of transforms. In those days, we didn't know these were called transforms, so we call them expanders. And some of these transforms, their job is to just basically massage the types, providing information that's missing. One of them is responsible for includes. So there's two aspects of inclusion, really. The first is the generation of the directives, and that's basically to say that for a given file, we need to know what's the right incantation to include that file. And then is the actual inclusion expansion. And the inclusion expansion basically means to associate a given file, I guess, artifacts as we call them, with a set of one or more includes, which we call inclusion dependencies. Now what should be happening is when we hit the inclusion expander, we should be receiving the serialization for declaration. And the serialization for declaration, as we can show, so if I now open up the templates for this, so if I go to C++, source types, formatters, now we're in the serialization facets, and in here there should be a forward declaration, such as this chap here. So what you're seeing here is a stitch template. Now we don't have any Emacs highlighting for this because we used to use polymode and that somehow stopped working. But as you can see here, what one would expect is that we would say, oh look, we need types, right? We need the class forward declaration archetype, and then we add that to the builder, and then that's it. Interestingly enough, if we return to our class A serialization, you can also see that there's a split free here. Now I found no evidence here of split free, so I wonder if we're looking in the right template. It should really be here. So let's have a look. We're definitely in serialization. These are the forward declarations. So are there any other forward declarations? Ah, interesting. There's a primitive forward declaration as well. Well, presumably we don't want the primitive one. So it's peculiar that this template doesn't seem at all to be able to generate something like this, to be honest. Because we don't have that, and we don't have that. Now we know for sure that the element we're looking at is a class, of course we do, because it's called class underscore A or A underscore class. So it's a class, so it should be using the class template. The plot is thickening really. Let's choose another random one, so class B for example. Yeah, they all look identical. So it's very strange, where exactly is this coming from? But whenever we have these sort of issues, one thing we can always do is we can always just make a random change to the code generator, just to give us confidence that we are really generating things. So for example, let's say I put a XXX here, and let's say I just generate Dogen.generation C++ .diam. Now, of course, we must remember that we are halfway through causing some havoc, so this is not going to compile. What we really need to do now is to get rid of all of this generated code, and that can easily be done. That's the magic of Wigit, and that's fine. That's the change we just made. I'm tempted to also get rid of that, but we'll leave it for now. So one thing I would love Magit to have is a way to mark a series of things and then just do one operation, like we do in diode, for example. It'd be nice if we had a Magit diode sort of view. Okay, so now then we can now build a code generator, which we will. And this code generator now will generate slightly mangled, should we say, files for declarations and serialization. So once that's done, we shall return to our reference implementation, and we're going to regenerate that model. And then that's going to either give us an XXX, confirming our theory that that's actually the right formatter, or not give us an XXX, confirming our theory that it is the wrong formatter. So let's just wait for this to do its thing, and let's continue to keep an eye on Dogen. It is quite interesting that this seems to always be the last build. Let's have a look at this guy. Same thing, also the last build. The ones that are doing the code cov, rather upsettingly. Windows is also doing this thing at present. In fact, I was hoping Windows would be finished by now, because the build was very... oh, it was very close to the end a second ago. Probably are building some reference simple. Which, to be fair, we don't even need to, because none of these changes really affect reference simple, but there we are. Okay, so we now have a code generator that well, it's mangled. So if I now say generate C++ graph impl dot, now what model are we in? We're in CPP model type. So now this is going to go away and generate the C++ model as it did. And what we want to do now is we want to have a quick look at Git. Right, okay, so that's a good sign. As you can see here, this is exactly where we want it. However, most interesting, it changed. Right, so there are two slightly different for declarations, and we were looking at a different one. Now let's just be very, very concentrated here, because this is difficult to follow. So A class for serialization, A class for this looks very much like the same file. A class. Ah, okay, so I see. The problem we had there was we were confusing the for declaration with the actual header file. See, this is not a for declaration, this is the header file. Okay, that's fine. So what we'll do is let's just pop over to C++ view in this project, and then let's just look at side by side all the stuff we have for A class. To be honest, we don't really care about types, so let's just look at for serialization. Right, so as you can see here, that makes a lot more sense. Okay, so the actual header, the real header for serialization, contains split free and contains all that other stuff that we saw a second ago. The serialization header actually contains a for declaration, so this is why we don't really have a loop. So we were just basically confused the previous video and probably hungry and didn't really think properly. So this means that the story that we raised actually makes no sense at all. There is no cycle. So let's, before we forget, let's find that story. We'll be sure that cycle in the title. Oh, here we are. Let's just cancel this story and say we were looking into the main serialization header, not the for declaration. Okay, that gives good traceability, so we know that we had these crazy ideas. Now then, so we are actually looking in the right place, but of course, as you can see here very clearly, the include of the type is coming through as you'd expect. Unlike in our case. Now, for good measure, let's just think about what's special about utility, right? First thing is it's inside of a namespace. So let's look at this model again, and let's look at an example of a type that approximates a bit better what we're seeing. Well, actually, before anything else, let's make sure our code generator is fixed. So generate, build a code generator, hop over to our friend here, regenerate the model, and the beautiful reversion of broken behavior. Okay, now then, so what I'd say now at this point is, do we have a slightly closer test? And we do. Here's a class inside of a namespace. Again, this looks very, very similar. This class has got the include as you'd expect. So it's not the fact it's inside of a namespace. That's good. The other thing we could ask is, are we generating a name and just basically builder is filtering out for some reason? So in this case we could just do something like std_cout here, one of my favorite logging prefixes. And so what we're going to do now is, again, let's just regenerate the code generator and build it. Right, so, okay, of course, so there is no include for stud, so let's just put, if I remember rightly, we can just do something like this. Maybe? I haven't done this in a while. Building the wrong project. This guy. And okay, we have a code generator that works again. Now what I'll do is just to avoid having to go backwards and forwards and generate and ungenerate, and this is a bit painful, we can just use dry run now for now. Oh, here we go. Dry run mode enabled. Can't quite remember how dry run works, so let's have a quick look. The nightly here, so we want to return to our layer. Right, here we are. Deeply nested structure. If I have a quick look at Dogen CLI, look for this dry run. Yeah, exactly. That's exactly what one would expect it to do. But just to double check. So, to be honest, is dry run really a diffing option? Okay, I don't want to get too lost here, but it seems a bit strange that dry run is a diffing option. Yes, it isn't. It's actually a processing option. Okay, that makes much more sense. So let me just fix that. Is there a processing area here? Yes, there is. So let's just take dry run from where it is right now, and let's put it together with the rest of the processing options. So I'll comment the next line if you need dry runs. Okay. And then what we can do is, let's just say, well, to be honest, this is probably goes closer to this, right? So there's the processing options. There is full generation stuff, and we just want dry run. Okay, now then, with our dry run in hand, we can generate utility. It's not actually going to do anything, But, oh sorry, let me just show you what I see. Righty, so you can see quite clearly that, well, something has been coming up. Not quite what I expect, but... So, now then, if we look at the stitch file for the declaration, well, clearly we're coming through here. Clearly we're attempting to find a header, but somehow Builder doesn't seem very happy, right? So now then, the plot thickens. What is Builder doing? And that's where probably we need to go into the world of formatters, maybe. We didn't really pay attention to what kind of builder this was, which is probably important. What we really want is the forwards declaration. And the builder that we are looking for happens to be a dependencies builder, clearly. Right then, of course, remember the dependencies builder will do a lot of dependencies building. In fact, we don't even need to go any further. Okay, right, so the problem here is very simple. We don't have forward declarations enabled. So I don't know why, but that's probably what's happening here. So, to prove my theory, what we need to do is to have a quick look at forward declarations in profiles. So if you remember, the forward declarations of serialization are including the forward declarations of types. And if forward declarations of types is not enabled, Builder would just say, oh, that doesn't exist, so don't bother including it. However, one would expect forward declarations to be part of all facets that get enabled by default. Surprising it isn't. In fact, there is no mention of the word forward declarations in this profile. But, of course, one thing we have to keep in mind, this chair is really annoying me now. It's time to spend some money in a decent gaming chair, I think. In fact, if you have any suggestions for a good, not too expensive gaming chair, let me know. I've noticed that we had a couple of comments in the videos, which is pretty cool. Okay, so what's happening here? Let's just look at what Dogen, utility is saying. It is possible that we specifically, here we go, we explicitly disabled forward declarations. Now I don't know why we did that, but we did it, and what that's causing now is, of course, that error. So then, well, let's just take the easy option out and say, don't disable forward declarations, I guess. That seems easy enough. And we go back here. Now let's just see what state the code generator is in. Oh, most interesting. We did a dry run, and the dry run wasn't dry. And there's a bug somewhere. Right, let's just fix that first before anything else. So why was our dry run not dry? This is not a good idea to... this is probably not why, but... this is not a good idea to reset all the options. So let's just try to run this thing again. That also means that we probably are not testing things properly. We probably still have the cached version of the enabling. Right, this is actually not being helpful anymore. So we'll just get rid of it. And then this is all generated code, so let's get rid of all that. Right, so the first thing we need to do is to make sure this dry run is working. And we do that by just running this thing again. In fact, let's just first run the code generator. Compile the code generator, should I say. Whilst that's going on, let's have a quick look at our cache. We'll make sure that full generation is off, so that's correct. Whilst that's going on, let's have a look. Oh wow, see ref impl finished. Okay, so what exactly does this guy have to say about code coverage, should I say? It's a rather long file. So we are eliciting the wrong directory. Rather interesting after all of that. Bit of an underwhelming finish. Let's, while we wait, get something else fixed. So we have a script somewhere. It's going to be an error in 2 different places to make life even more interesting. Right, so stage there. And as you can see here, lovely. Stage there is $1. What is $1? Okay, we've done something really silly here. This is just a copy and paste error. Okay, let's just fix this first, and then we resume our analysis, so we can push this and wait for the next. So here we should also have another coverage script. That's probably not what we want. We just want the Travis YAML from Dogen. This guy here is doing a few things, including this stage there. Now I'm not entirely sure, and this is one of the reasons why I do not like handcrafting these files. They should be really code generated. I'm not too sure if our Travis YAML knows of the staging there. Indeed, hence why it's really not very happy. The Dogen one does. So we just copy this block and we have a look at what this chap is exporting in the install portion. So we don't really need projects directory, don't need ref impl, we do need stage there. Okay, cool. So that is now going to point to stage there, and that should hopefully address the current problem at hand. So if you say something like Travis set stage there environ variable, so coverage script is not working because we have not set up the stage directory was. Okay, that should help us out, and then what we'll do is just swap over to git, and here what we'll do is we'll just push this if we can measure, so we can see what happens in a few minutes. And then next time we're waiting for a build, we'll continue this work. Now then, what we were saying was we were waiting on a build, which is done. Now we have a new code generator. Now what we want to do with this new code generator is we want to generate utility, and we want to make sure that dry run kicks in, because it was, no, it's not kicking in. This is worrying, very worrying in fact. Okay, before anything else we have to figure out if we broke dry run, because this is very useful. The test should have picked it up, to be honest, but I'm concerned. 16:16, which is the time now. These are the options. Let's see what we see as our configuration options. You can see why it's so easy to get sidetracked. You start doing something and then... Okay, dry run enable is false. Okay, fine. It's just slightly less worrying. We should probably just look more carefully at the CMake file. We try to be quick, and then by being quick we end up taking longer. Right, let's look very carefully at this. For your stupidity, really, isn't it? We did a half of the job. Most of the time, problems in programming environments tend to be just trying to do too many things at the same time, particularly in a proper professional environment. At work, we tend to have to do about 20 tasks at the same time, and we never have the time to reflect deeply in what you're doing. And that is also what happens when you've got a video such as this, because I'm trying to think and talk at the same time. I've noticed my productivity has gone down slightly by doing that, but at the same time my motivation has gone up because creating the videos has made me actually work a bit longer hours, which I found a bit surprising. And that's the thing you need to do when you're in a project such as this one, because it's such a long project, so many years of working, and so many times you lose the plot. Right, there we are. Dry run is dry running, as expected. So let's not dry run, shall we? In fact, let's just be very brave here and assume we're gonna fix all problems of the world. Right, so then this is no longer a dry run, so generate the model. Git will show us a whole load of changes, and compilation will kick in. Now, one thing we want to do in the future, this is a story we have, it's a notion of satisfiability. I've started thinking about how we're going to solve this, and it's actually a fairly interesting mathematical problem. We just don't have the time to look into it now. But it's entirely possible to use solving to determine when there's incompatibility between features. I mean, if you read the literature, there's lots and lots of papers on this kind of thing, where people are talking about configuration variability, and they're talking about how do you determine if a configuration is valid or not. And that's exactly what happened just now. We just created an invalid configuration from a perspective of C++. And so Dogen should be clever enough to know that if you're including a file, and if that feature that generates the file has been disabled, that you've got an unsatisfiable request. This is entirely possible to compute. It just requires a little bit of maths. We need to generate a graph of all the dependencies, and then we need to generate a vector of booleans for each feature, well, containing all the features. And then we need to basically figure out if there is any, if you're attempting to do something that's not satisfiable given the state of the graph. Okay, so that looks very good. What we're going to do for good measure is, because this happened, this is not going to be the only place where this has happened. So I'm going to very quickly undo all of this stuff. And as you can see, the tests compiled, so I'm happy. Now, what we need to look for is this for declarations enabled line. Now, clearly, in the past, this was a thing we used somewhere, which makes me wonder if we used elsewhere. And if we did, it's going to be probably a problem now. So let's just look for, well, to be honest, we just want the dia models, because if it's in dia, we'll be in JSON, so. And as you can see, it is used in other places, right? Right, so, well, if it's set to true, it's not a problem. What it is a problem is if it's set to false. And lo and behold, we have it in certain places. Funny enough, it's in utility, so let's just look for false here. Dogen.dio and utility. Okay, before going any further, let's see where utility has this. It's not at the top level, so it must be in a type. Oh. It's probably because I thought we had removed it from logging configuration. Nah, this is the exception itself. Alright, so this is an exception. Exceptions are actually not serializable, so that's not necessarily a problem. I'm just leaving it like that. For assets, true, that's not a problem. Dogen.io, this is slightly more worrying. If it's an exception, it is an exception, so that's fine. We probably should really, I mean, there's several things here, right? The first thing you're going to say, oh, well, we probably never use for declarations exception, so wouldn't it be nice to just say that? also that all exceptions have no forward declarations. Yeah, and it is going to be possible, yet another feature in the Dogen backlog. We just haven't got around to doing it. I think if I look for false here, the only two cases, I'm happy enough with this. I'm going to believe that this is good. So all I'm going to do then is to say convert, and then I'm just going to indent the JSON, and then now bear in mind we don't want the profile change, we just want okay, we work the JSON. Right, so it's actually easy to do this change by hand. So we do not want the profile change, so we'll just remove that from the diagram. And well, let's just do it again then, shall we? Convert and now hopefully these are in two different hunks, which they are, and I can just really right. So what we're going to do then is in our compilation window, we're just going to run all tests. Right, this is going to go away and do its thing. Now let's resume our code cover adventure, shall we? Sadly, as I say, we seem to always build Clang debug last. Meanwhile, what happened to Dogen? Oh wow, I actually finished the Dogen for Clang. So hopefully we're not going to get the same error in this one. Oh, it's very unlikely given the script is different. Coverage. Oh, most interesting. Oh, I thought that we had put start tests. Clearly we didn't. Okay, you broke something again. Let's have a look at the coverage script. Should have been start tests. Oh, the score. Oh, we need to quit from Git Time Machine. There we go. So what we'll do is let's just resume our tests. Let's make sure everything is green. And we'll probably, for good measure, just extraction model. Oh, oops. One thing we did forget to do is to regenerate the model. Remember we said we wanted to generate 4 declarations. That means the model will change. So let's regenerate the model, and hopefully we'll see a 4 declaration there. And then so whilst we haven't gotten an absolutely amazing coverage, and you'll see this in a minute once coverage is up and running, it's actually not too bad when it comes to what I really care about, which is has the code generation changed? Well, to be honest, we probably should just say the problem was that we requested forward, but we disabled forward declarations on this type. Enabling it fixes the issue, and that solves the problem at hand. Okie doke. So now then, let's do a couple of commits. Okay. So this is why I love fix me's, because you always look at them. Alright, so not put spurious white space, always annoys me. The dry runs are commented out. Full generation is moved over here. Generation is nice, and dry run is moved. Okay, cool, that's good. So let's just do that as a separate commit. So in here we'll say, shall we say utility generate forward declarations for logging configuration. And then here we should say scripts fix no fix regex to find tests in staging here for coverage. And finally, last but not least, we should say here cmake tidy up use of try run in Dogen options. Which is kind of what we did really. So let's just jump over to Git. Alright, so we think we've got enough now to attempt another go, have another go at running the nightly. In which case we will, in fact, this is where I, because we keep jumping shells, we should really create another shell. And if you just rename it to shell nightly, so we don't have to be CDing every 5 seconds. It's quite annoying. Now then, what we need to do here is refresh our script. We really where is our script cruncher? Well, first thing is we're just going to take this. Well, first thing, we don't really want all those hacks that we put here. Remember, commenting things out is fine on the nightly folder because that's not the committed thing. But let's just not hack too much the file is in Git, because otherwise we will forget about it. Right, so now then, what we want to do is, so we don't really want to build all of that stuff. Oh, of course, we must remember we renamed the builds to experimental, I believe. No, it's not from here, it's from here. So experimental, yes, that's correct. So we just have to remember, this is another point we should have, as always, whenever you do hacks like this, it's very, very important that you put fix me in them. I keep forgetting to do that, because as you can see it goes red and it shows up in a diff. So it takes 5 seconds to spot the error. Now we don't really want this, and we don't really want this. We don't need to clone. So, well, actually, let's think about this. We want to regenerate everything again from scratch, don't we? So let's just not be too hasty here. Let's actually test. Let's actually test the workflow of cloning. So we will remove the existing folder. We will clone, we will copy to get the pristine. We will run the build to generate the code generator. We will generate all the files and we will do the builds. Okay, I'd rather do that. Let's go to our nightly shell then. And let's just fire off our cron. I just want to start, and now you realize why I wanted to RM and as RF. It's just that you have no idea what's inside of that in that folder, right? You've been faffing around with it, and you've been, you know, Lord knows what we've been doing to it. And so if you don't delete the state of the folder, you end up with lots of weird and wonderful errors that are going to be hard to explain. Now, one thing we need to do often with upveyor is we need to cancel builds. The reason being that, as you can see here, there's some chaos. The reason being that upveyor is very slow. And if you don't start cancelling some builds, you're just going to have a backlog of builds. Dogen looks alright, so okay, I'm not going to bother with that at the moment because there's only one build each. But I bet you if we look at C-, we also need to start deleting some builds because C- only gives us a number, fixed set of builds. I see just some weirdness going on. Right, first let's just get rid of all of the experimental builds because we don't really want any of these. Oh, actually, sorry, are we on reference implementation? Well, it doesn't really matter, but let's just delete a few of these, really. You got a build coming. I mean, builds are only useful for a period of time, and then after that, don't particularly care. I mean, I would love, of course, to keep the history of every single build you've ever made, but given that free C dash doesn't allow you that, then the next best thing to do is just delete whatever. Otherwise, you spend hours on end finding the optimal number of builds, and I find that it's just easier to just when you're building a lot, which is what's happening today, easier to just trash a whole lot of builds. Particularly these ones that are red. I don't like red builds. And now we get to 12 minutes ago, 32 minutes ago. These are recent enough. Let's have a look at Dogen, because we probably are also running out of builds in Dogen. Well, here you go. Let's get rid of our experimentations. Probably not enough. Maybe up to an hour ago, I guess. Sorry. Okay. So now then, not entirely sure. Okay, right, so we just finished building the code generator. The code generator kicked in, it generated. Of course, because we pushed everything, we should get the latest of the models. Bit of water. And then I think I noticed as well is that I drink a lot less water since I started doing videos. I tend to go through a lot of water when I'm by myself, not recording. It's not so practical when you're recording. So at this point in time, where are we? Around an hour into this video. Oh, as I explained before, here's our VM where we build Kickoff. And, well, we still haven't tested Kickoff. Hopefully one of these builds points will do the right thing. Oh, is this it? I'm losing track of the builds now. I'm not quite sure if this build contains the latest. And okay, we seem to be doing something, and we seem to be submitting something. Okay. Right. So at this point in time, if we look at CodeCov, we should see some updates. This is coveralls, not CodeCov. In fact, let's just test. Nothing happened here. Ah, coveralls. Okay, so we seem to be updating the coveralls. So I'm not entirely sure which one is the one. Oh no, actually remember, this is the impl model. The impl model, not everything. So, what do we see? Graph impl. 91%. Got into the 90s. Seem to have increased coverage. I guess this is good news. Just for good measure, let's just return to the project and hop over to there. Oh, not that guy. So that was coverall. So let's have a look at CodeCov. So in CodeCov, let's log in. And in CodeCov, that's fine. Oh, interesting. Is it the case where? Ah, okay, that's because we probably This is peculiar. I thought that oh right, it is. Okay, right. So I'm not going crazy. The MASD project is here, and as with the previous one, you can see we're finally reaching 90-something%. Now, what are we saying with this coverage? This is very important. What we're saying is this is the reference implementation model. Of the reference implementation model of the generated code, 91 point whatever, 91% of it is being executed. This is good. And what this will show us now is if we choose, let's say we browse the report, if we choose something specific such as, well, to be honest, I want to see, rather than the report itself, I want to see current state of the world. Like what's red? There we are, this is what I wanted. What we expect to see here is utility. I didn't expect to be that bad, but it's bad. And north wind. Okay, so this is very good, because the reason why north wind is so low is because all of the ODB code is not being tested. Oh, interesting. We're not seem to be building ODB. Why are we not building ODB? That is unexpected. I would have thought that we'd be building ODB in Clang. So if you have a look at this build, as you can see, this is never ending. We go from one problem to the next. So in this particular build, yeah, so ODB feature test project has been added. And Northwind, yeah, we are building ODB. Oh, I think I know what the problem is. Yes, okay, interesting. Right, that's yet again another problem, and that nightly took not long enough. Okay, the problem here is that our coverage script has a bug. We are probably... Oh, I was going to say we're excluding... Excuse me. I was going to say that we're excluding CXX files, but seems Kekov is cleverer than that. Okay, this is time for another story because otherwise we're going to get sidetracked. Right, we consider this one done because we are now uploading code coverage, so I don't really care about that. But code coverage does not include ODB files. The latest code coverage reports are excluding ODB files. You need to understand why Kekov is ignoring those. I have very, very deep suspicion this is related to the extension. Very deep suspicion. I would also say that this work has fallen under CodeCov. So what was the last story we clocked? 1641, 1541. Testable perhaps? Oh, we haven't clocked anything on that for a while. Could it be we haven't been clocking since... yes, I think we have. So this code coverage story ends at 1541. So I would say... Where were we? We needed a story for... here we are. Full generation produces invalid code. So that is all the way to 626. Now I'd say the rest of the time from 1626 was in code coverage. So up to now. Okay, and I think this is fine. So let's just say if you want to go back to the problem, just go up to this guy here. We can measure it. Let's just give it a nice name. These coveralls, CodeCov. Okay, so that's captured. We can move on. Now then, let's return to our nemesis, I guess. The test build. Why has it failed now? "17 errors." Most interesting. So first let's have a look at what succeeded, because this still seems like a lot of stuff have worked. Though we do have 3,000 tests failing. There you go. 17 errors. Okay. Ready, so we are trying to do serialization, relying on register types. Again, this is really why we need to start generating everything for all the facets, because I'm sure this is not being tested by the test models. So let's have a look at this model, variability. Variability, this is the model where we handle all the metadata related stuff. And what type in particular are we looking at? Registrar. Excuse me. Let's have a quick look at what this stuff is all about. We seem to have ended up in the wrong area of the world. Right, so variability. Source type. Of course, now this is where things become interesting, of course. Remember that we have the nightly builds, and we don't really want to start confusing things. So what I'll do is I'll create another area here, and let's just call this area nightly. And in this area, so for good measure, what we'll do is ensure we're nightly, right? So you can also put the show of the nightly here. Okay, so in this nightly area, we'll just stick to buffers open in nightly, so we don't start confusing things, because last thing we need is start committing things in the wrong git. Right, we are inside of the nightly builds. In here, there'll be serialization, and there'll be a registrar. This should be including register types. And it is, of the models. As you can see, the idea with register type, I mean, this is actually quite interesting, because if you recall, the bug we're having at present, if we zoom out all the way back to part 1, the current job that we're trying to do, that we're failing miserably at, is we're trying to move registrar from here to the meta model. And we have moved it, but for some reason it's not working properly, and we need to get more information out of the system. That's why we're trying to create the relational model. As it turns out, the bug we're having at present is exactly with registrar. It's a bit of a coincidence. So what the job of registrar is, in boost serialization, whenever we have inheritance, you need to tell boost serialization about it. And that's the job of this registrar. And what registrar does, it registers a whole load of types, as you can see here. It's registering many types. Now then, your according to this nightly build, we seem to be struggling to create a polymorphic reference of O-archive. Now the reason why this is because we tend to force the instantiation of these types, as you can see here, via these instructions, I guess you'd call them. We want to make sure that C++ really, or the compiler really generates these, because these are all templates, right? And the idea with these templates is that we want to make sure that these things exist in the binary, because what's going to happen is we are going to be calling register types from somewhere. So for instance, in this particular case, we're calling register types from Dogen, the top level one, or we could be calling from archetypes or tracing. And whatever template incantation that was used, we need to make sure that that template incantation is available and was generated. Not entirely sure why this is not done in HPP, to be honest. This was done a very, very long time ago, and it kind of worked. Or maybe it didn't, and we're just not testing it properly. So let's have a look at the include of serialization. So there he is. This is the template. And what tends to happen is you would call this guy here, and this guy, via this magic incantation, would then result in a link to a symbol that exists because we force declare this. And that I think used to work fine, so I don't think that's the problem. I think the problem may just be that we're not linking correctly against all of our dependencies. So if I'm right, if I look at source, I wonder if we are, as you can see here, we're linking against archetypes in utility. However, if I look at that guy, we are calling Dogen and tracing. This is very puzzling. Just for a laugh, what happens if I say dogen.lib and dogen.tracing.lib? And what we'll do is, we are in the nightly, so back to where we were. You notice that LSP is not working. I just don't think we're going to be here long enough to justify fixing that. Hopefully. So what we'll do is, instead of wasting time, we're just going to go straight to build output and clang 9 release. And in here I'm just going to do ninja minus j4. And I want to see if this made any difference. And whilst that's going on, we can have a look at who else is moaning. So variability, plenty of that, and that's about it. So I wonder if this is as simple as linking issues. Clearly this can't be good, that we're not linking. Seems slightly happier, but might as well wait until this is finished, really. So whilst these 2000 translation units are doing their thing, we shall return to our mission of getting Dogen to give us some. Oh, again, Dogen is still not there yet. Okay, okay. Well, so the other thing that needs to be looked at whilst this is going on is how are we gonna generate coverage from the nightly. So from ctest, there is the notion of coverage supports. Let's not call this coverage. And I believe we have disabled coverage. Well, we haven't enabled it, so it must be disabled. Now, what is the easiest thing to do coverage? Let's see how does coverage work in C dash. Ctest coverage, because what we don't want to do is we don't want to upload the coverage over to ctest. It does have coverage support, but I mean, we already have these other tools. Seems a bit silly to upload to everything. Let's see what this chap says. Okay. Right, it's not quite what we're looking for. We just need the command that generates coverage, and I'm sure it's quite a trivial. There's a CMake list, there's a ctest config, ctest, right, so in here there's the ctest coverage, aptly named. And right, so collect coverage tool results and stores them in coverage XML for submission to the submit command. Options are build directory, and so presumably we could upload coverage, I guess. Nothing stopping us from uploading coverage, but what exactly is the coverage command, one wonders? Let's just look for the coverage command. Make sure no one's trying to talk to us. Reply in a second, nothing important. Or maybe if we just say something like, can I use kcov? Kcov may be a bit too advanced for CMake. It's not so obvious. To actually run the coverage testing, you need to have tools added into your add tests. Then you need right here. You need a ctest manager script that's called ctest coverage, or use one of the predefined coverage dashboards. Help coverage. This looks rather complicated. I was hoping we could just run a command. Clearly it's never that easy. On the plus side, our nightly... Oh! Let's jump on a little bit further. Oh, similar problem. Okay. But in a different place. Injection.dia. Okay, right. Let's just rinse and repeat here. So in injection.dia source serialization register. Here we have, wow. So you can see a lot of things. And in source we have a few things, but not everything. So what do we need? Oh, injection is here. Good. Interesting. Now we have extraction. Injection is a reference to extraction. Now that is rather puzzling. Not entirely sure why. Injection model would be referencing something that happens much further down the pipeline. Seems to me like a typo. Yeah, I think this is a mistake. Right, so let's do two things here. We're getting into proper development in a nightly directory, which is what we're trying to avoid. So we have two things. First, we have to remove that dependency and sort it all out. But for now, this is really ridiculous, but we just added a reference to extraction. I'm not sure what this is going to do, because it's probably going to create a cycle. We have a reference to dia, of course. Injection, extraction, dia, and Dogen.tracing. Thank you very much. Dogen.variability. Dogen.archetypes. Outlet. And of course utility. So what we'll do is, this is clearly wrong, but let's just see if this causes problems. If it works, we will fix everything properly in our actual work area. Seems to be going a little bit further. Let that keep going. Now then, coverage. How do we get C-test coverage? Oh, the coverage analysis is done per target. Whoa, no, this is absolutely insane. We are running hundreds of tests. Kickoff is very, very efficient. Okay, we're definitely not going to do this. Okay, so what is plan B then? Now let's just resume our work area. What we need to do is, in our script for the nightly, where we have coverage.linux, we have some current script. So what we can do is we can say just run the coverage script once we're done with the build. I mean, we don't need coverage for these chaps here because we know it's good. So we will just basically say, yeah, okay, I understand that you've got all of that, but we're gonna ignore C-test altogether. And so what we'll do is we'll say something like, if you remember, we're inside of the git there, so we could just say something like build scripts, and then build scripts coverage Linux. Now we just have to be very careful about how we run this script, because remember, we're no longer in Travis. So Travis, okay, so we want almost all of this. So we need a station directory. This chap here, which we'll fix in a second. So we'll just do something. We don't have to export anything really. We'll fix that in a minute, and then we need to say something like something like this, and we already have some variables here. So, oh, actually no, let's not do that. Right. So, what is the staging directory? Well, I think this is a little bit too elaborate. We know what we want. We just want Clang. So, is there a compiler? There is a compiler already, so that's good. The configuration hopefully is debug, so that's good. And we don't need the Travis there. So, if we just say something like build scripts coverage linux.sh, and then we should have copied the rest of the command, shouldn't we? So this guy here, Travis job ID, and then stage that. Okay, there is no Travis job ID, sadly. So this is a much easier way of doing things, right? Just make sure we then Clang. Then we just need to submit coverage.linux, because we're not sending the coveralls, you should only send it to the other chap. Okay, that looks very good. Now let's just see how far our build's gone. Not very far at all. Engine. This is rather painful, but to be fair, engine is not far from the end. Quite close to the top. This is the orchestration. So as we always do, we need to locate serialization registrar, get the number of these crazy critters here, and then find this guy and see what we missed. So we have assets, we have ourselves, we have extraction, we have, surprisingly we don't have tracing. No, we don't have tracing. Tracing, not live. We have injection, we have generation. Yep, we have generation. We don't have variability. And we don't have archetypes. Okay. Yet again, we just give it another go. Go to the next problem. Assets this time round. Assets. Again, we have a few things here. Let's compare that to what the linker thinks is linking against. Missing archetypes. Okay, so variability tracing and extraction yet again. I'm very curious as to why we have extraction so many places. It's either some kind of typo propagated, or right, so what's happening here is that depending on the configuration that we use, this is actually really a bug, but it's a bit annoying. We kind of need to run this on the nightly now, or we need to at least export some variables from the nightly. So if I just return to cron, I just need to export at least one of these guys. C++, ref, impl, and so this is going to be something like pwd, and that's going to be presumably C++, ref, impl, projects. Now with a bit of luck, CMake didn't trigger, interestingly enough. Okay, sorry, wrong version CMake. Ninja relative 4, 6 even. Oh, excellent, we started all over again. That was a faffing around with CMake. Hopefully this will solve that issue. Right, okay, so we're still waiting for Dogen. Oh yes, Dogen has done its thing. Now then, according to the very complicated logic, we now have to figure out which project we should be looking at. I believe it's coveralls. This coverage should have gone down dramatically. Yes, correct. Now we've gone down to 39%. I mean, this is actually worse than I expected because since we removed all of the generated code, I was hoping the coverage was a bit higher. And really, where it really matters, it's not too bad. There's probably a few projects here where we are quite short. Now this is telling us the truth, which is basically to say, excuse me, which is basically to say that of the manually generated, the manually created code, we don't have a lot of tests. Now, of course, there's also code here that's not just manually created, but really you would have thought that code would be called from somewhere, right? Interesting, we have 2 inches of configuration. This kind of tells us that we are... interesting. Not quite linking to the right places. That is a bit annoying. You seem to be creating a report with /Dogen. Okay, so yet another problem. Let's raise it in the ticket for this, another story. Code coverage does not show file level results. We seem to be pointing to an incorrect location on GitHub to find the source code. Example. Okay, and as you can see, work just expands almost at an exponential rate, because you keep looking for, well, trying to fix something, and then you end up with loads of other problems. It's rather annoying. Just for a laugh, this code cove suffers from a similar problem. No, that is actually fine, except doesn't seem to be. Okay, we have 100% coverage according to this. Let's try something with slightly less than 100%, shall we? Nothing. I'm sure the source would have some example. Okay. Yeah, so whilst this is showing us the file, it's not actually showing us where in the file for coveralls we do seem to be able to see the file itself, but not the lines covered. So it's a bit of a disaster, but the key thing to remember is we're always looking for the perfect state where everything is working, everything is fine. The reality of the open source projects is that that state just doesn't exist. What exists is something that's slightly better than we had before. So I think we're definitely in a better place because we have some kind of coverage. It's not ideal because we can't do any analytics on the coverage, which is what we wanted, to see what's not being covered. And that's very important so that I know where to do work on the generated tests to cover things. But we need to, at some point we need to call it a day on some excursion and keep going with the actual thing that we're trying to do. So this is going to be a mission for another sprint. We have got coverage of some kind. May not be the best, but it works. We will have to worry about that later. There's nothing else that can be done. So all we now need to complete this task, which is rather important, we need this nightly build to work against all generated tests. And for that, that will probably be the last task for today, really. We're approaching the end of our time. It's already gone best part of an hour and a half. So what we're going to do is, while this chap is doing his thing and we wait for the next error, we shall try to start fixing things. So I'll just get rid of this and look at git inside of the nightly, and hopefully it will. Sadly, it's now going to show us a lot of things, because of course it contains all of the generated code. What we really want here is CMake. It's not so easy to spot CMake here, but and so what we'll do is we will one by one look at these chaps. So variability to me looks not too bad. These two dependencies are sensible, I think. So let's resume our actual Dogen work area and look at variability. And here I believe we're telling the truth. We really should be linking against Dogen and tracing, because we are using those two libraries. So that's not a problem. Next, CMake. Injection. Now injection, I think... Injection die, really. Injection die, I think we are lying slightly, because I can't see why injection die would ever need to link against something like extraction. So what we'll do for this guy is we'll just say, why do you think you need extraction? And there is no reason according to this. So what we'll do for this chap is we'll say, what happens if we remove a reference to extraction? There is no good reason for this reference, to be honest. And Dogen is not clever enough. This is something that's missing. Dogen is not clever enough to detect unused references. I have a story for this. So if I just generate injection out the Dogen.injection.dia, and if I have a quick look at the result of this generation, in effect this is good, nothing really changed, because of course we're not generating everything, so we don't expect anything to change. So now if I go to source, and if I change, so injection is there already, extraction we don't need, tracing we need, variability we need, archetypes we need, and utilities there already. So tracing, variability, and archetypes are missing. We should really have an order of linking. We used to, but we haven't followed it properly of late. How's the build going? Oh, next error. So the problem is in Dogen CPP now. So yet again we will pause. Look for projects. So it must be generation.cpp. Sorry, there is no such thing as Dogen.cpp. Serialization, registrar. And in here we see a number of these guys. Whereas in source we see less. So extraction here makes sense. And there is extraction. There's also assets. There is no generation, no tracing, no variability, and no archetypes. So let's see if I can just quickly fix up this. Right, so tracing, make sure we don't have any duplicates here. I think it looks about right. And since we're doing, well, actually let's follow that order there just so that we don't get confused. 309, that's actually getting quite close to the end now. So where were we then? We were in injection.dia, which I believe we just did. So the next one would be perhaps if I just say CMake, okay, engine. Again, engine looks good. So we seem to be missing some link. And of course, none of this would be a problem if the CMake files were actually being generated by Dogen. It's not the case just yet, I'm afraid. So presumably these are all missing here. So return to 9. Oh, look. It actually is green now. Interestingly, we seem to have very strange errors. Ah, very good, very good. Composite object metrics. Okay, excellent. So what we just done here is we just figured out that there is a problem with objects where there's a cycle. That's very good. This has already revealed an issue. This is very, very good. Okay, so let's just continue our track. Let's just look at assets now. Assets is here. So let's just have 2 for assets. I'm extremely pleased that we've done this because something we've been meaning to do for a while. Okay, so asset seems to be the last one. Okay, very nice. Assets is done. Actually, don't think we did C++ generation. We didn't, so perhaps we skipped. Right, variability we done, injection we done, engine we did, assets we did, and looks like someone is talking to me. 1 second. Okay, so we had a bit of a large pause. I had to handle some other stuff downstairs, so I'm hoping this video will record correctly. So now I need to get my head around what we're doing. So we figured out that the tests are actually revealing us very important problems on composition. We'll leave that for a minute. We fixed in our Dogen everything that required fixing. It was largely FuseMac file fixes, and we never quite got to the oh yes, we did get to the bottom of how to run code coverage, which we did by just attaching that. So in fact we are good to go really. This script is good enough to start running tonight. So one thing we didn't do, we probably should have. Probably should have attempted to do a full run here of script. And probably need to copy the script again. And no, actually before we do that copying, we had, no, to be honest, there's no point. We will just run that tonight. We'll leave the script as is, exactly as it is, and we'll just run. We just have to make sure that we are not commented anything out. And everything looks good. Okay, cool. So this is going to run nightly tonight, and we'll see what happens. We're going to have a lot of breakage, but that's fine. Might even be tempted to disable tests for those types where we know there are problems. There's some kind of composition. In fact, let's just do that. Okay, so before anything else, let's just attempt to build after all these changes and run tests. Now we know for sure we need to sync the JSON model for injection. It's a quick thing to do, but since it doesn't affect the output, it's not a problem. So convert Dogen.injection.dia presumably, and then we indent, and now we got the JSON changes, and okay, there's no point in doing this because it's all in the same section. So right, so what we want to do is get rid of this extraction reference. Right, so then we can basically say models remove reference to extraction in injection dia, And then we could say CMake. Oh, one thing we did not do is, whilst we were away, which was roughly from 20 past, I guess, let's say. Probably less than that, but let's call it 15 past. And then we return maybe about, I don't know, 5 minutes ago. And we can just clock that so we can check everything in. Right, so we CMake add missing linking dependencies, and we probably should promote this to nightly again, I guess. So scripts, adds code, coverage support, and ctest, cosmetic fixes and messages and coverage messages. And finally we just add a backlog grooming here. Now I'm not going to close the story on the nightly because I think we're still going to have a few bits and pieces. Okey-doke. So let's just double. Oh, we got to 9,900 commits. That's good. Let's have a quick look at where we are in terms of the builds. Dogen looks green. We know that we know that it's pushed all of the code coverage. RefImpl is still going in his own little merry way on Windows. Eventually it will get to Dogen. It's very, very slow. And what we'll do is pushing this now will make it even slower. So that's all good. This is going to now result on a nightly that's almost there. Now what I'm going to do is, because we know exactly where the problems are going to come from, part of me says, why not, where is our nightly shell? Why not have a quick look at these types? So what you can see here is composite, composite tests. So Dogen.io. I think the problem is that in Dogen.io, well, composite, the name says it all, I guess. Wrong model. It's type composed of itself using the composite pattern. Those using a boost SharePoint, I think we have some kind of problem, either in test data generation or something. So what we'll do for now, we'll try to do anyway, is to do something like Dogen mass.generation.cpp tests.enabled equals false. So if this is the right incantation, double check that with something. mass.generation.cpp. Let's look at the profile perhaps. Mass generation CPP tests dot enabled. And now I think that should be sufficient to stop this guy from generating tests. And I'm not sure this is the only place where you have this problem. We definitely have it in tracing, because metrics contain metrics, and we may have it in other places. But I don't know. Let's just try these two first. And what we'll do is in Dogen we will ensure that generating all models doesn't break anything. It doesn't generate any spurious diffs, and it doesn't. And now we just have to make sure that we do convert Dogen.dia, and then indent, and similarly convert Dogen.tracing dia and indent JSON. And as you can see here, few seconds more, won't count I guess. We'll have to call it a day in a second. And so we're just going to basically say something like models disable tests for composite types in tracing and dia models. And so with this commit, hopefully the nightly build will not generate tests of these types. We'll see this tomorrow morning because I'm running out of time for working today, so I'll just wait for the nightly to kick in. Just push this to master, and hopefully, it's a bit annoying that's at different heights. Push this to master. Dogen build is already kicked off, so let's just have a look at the projects, and it's very green, this is good. And this chair is also misbehaving, so Dogen is kicked off. Okay, so this is not too bad. So to recap what we've done today, then we've well, let's have a look at the commits, because it's been a bit of a haphazard session with all this stop and start. So on the second session, we've managed to figure out the problems that we had with 4 declarations that was causing the test to fail. Basically fixed a number of issues with our nightly when it generates the code for everything. We're now down to what we think might be the last issue, which is we have tests that are actually failing the nightly, and now we know why that is. We know the composition is not very well supported, so we need to find a way to move on and just log that as a ticket. So hopefully to the next part we shall look at the nightly build and see how well that's going, or badly I guess. That's all for today. Thanks very much for watching.